Thank you for your introduction. We are very honored that Satsukita 81 has received such a great award. I'm Satoshi Tatsuno of Taisei Corporation. I designed the structure of this building. Thank you for everyone in this project with us, owners, designers, contractors, concrete companies, and more. Now, let's start my presentation. Sapporo, Hokkaido is Satsukita 81 is the tallest building in Hokkaido. This is 48 floors above ground and about 175 meters high. There is a lot of land to build in Hokkaido. However, recently, high-rise buildings with the value of near Sapporo Station are demanded. These are the inside of this building. This is description of concrete usage. In this presentation, I'll explain these technologies that we newly developed and adopted. First, precast construction method with hinge relocation method. Hokkaido has a lot of snow, so construction work is restricted in winter. To shorten the construction period, it was necessary to use precast members for the entire building. Japan has a lot of earthquakes, so tall buildings are designed with a moment frame structure. Especially in a super high-rise building, the structure is a complex concentration of rebar as beam conjoint. A high viscosity concrete is difficult to cast inside. It's best to use full precast columns. So all columns were full precast members. In addition, beams of 2 floors and above, slabs, balconies, and corridors were made with half-precast members. As a result, about 65% of concrete is precast members, so we achieved a 5-day cycle per one reference floor. If concrete was casted inside, it took about 20 days. Not to mention, the formworks of concrete members were greatly reduced. Second, hinge relocation method for improvement of seismic performance. To avoid the damage of beam column joint relationally, the hinge relocation method is adapted. The plastic hinges are designed at the shifted position of the beams using high-strength rebar and mechanical joint. We did various experiments and verification, and over a long time, we use this method. We can use this method. In Japan, the design and construction may be contracted by one company. In this case, structural designer consider what the best construction method is. This shows hinge relocation method is applied in the construction site. The precast columns and beams are simple and completely separated. Also, the extension of the beam and bars is short. Hinge relocation method has great advantages, not only improvement of seismic performance, but also in manufacturing, transportation, and construction. Third, ultra-high strength concrete with design standard strength FC 100. In Sapporo, conventionally, we use FC 70. FC 70 is the upper limit of ordinary concrete. by solving these many problems in advance, achieves both high strength and frost resistance, even with a 2% air value, contributing to the reduction of environmental impact, and etc. in advance. We are able to use ultra-high strength concrete FC100 in Hokkaido first time. Fourth, take-up system. Take-up is an advanced construction technology that has never been before. This system uses arch-columns of the building instead of the tower crane mast. These are how take-up affect construction. No floor remains uncompleted, and we could install at any position. This project is the first step of this system. The take-up system was realized using the hinge relocation method because the extension of the beam and bars is short. Next, a video of take-up system. It is possible to climb in about 1 hour per one floor. So the impact on the construction process is extremely small. It greatly contributed to the 5-day cycle per one floor. Finally, we will show the production drawing creation system of precast members using beam data. It saved a lot of effort in drawing. That's all. Thank you for your attention. ありがとうございました。